In Lesson 5, we're going to learn how to actually solve by factoring. As we mentioned before, solving by factoring is one of the ways that we can solve a quadratic equation. We're going to use something called a zero product property to do this. How does that work? Well, you've learned how to factor trinomials into binomials. So the zero product property helps us get to the final end goal. Basically, a zero product property says that anything times anything that's equal to 0 must mean that one of those factors is a 0, or both of them are 0. So, for example, if I know that a times b is equal to 0, then either a or b have to be 0, or they both have to be 0. And you know this because anytime we multiply anything times 0, our answer is going to be 0. So we can use that for our factors as well with binomials. So if I have something like c minus 5 and d plus 3, and I set those two equal to 0, then that means that one of these binomials is going to have to be 0, or both could potentially be 0. So how does that help me solve an equation, a quadratic equation? Well, when you have a trinomial or a quadratic equation, you're going to factor out, and you end up with two factors like we have here. If we set one of the factors out, c minus 5 equal to 0, or d plus 3 equal to 0, we simply have an equation that we can solve, and we can get our answers like that. C is 5 and d is negative 3. And you can plug it in to check and see if this works. We know how to solve one-step equations, and so this is why solving a quadratic equation by factoring is actually kind of easy. We're able to get our values from setting it equal to 0. Now, one of the things that you're going to have to realize is that quadratic equations, as I mentioned before, are univariate. That means that you're only going to have one variable. So this example that I gave is probably unlikely. It's probably going to be c minus 5 or c plus something, but it's not going to be two different variables. The example that you're probably going to get is something like this, where you have a trinomial that's equal to something other than 0, and you're going to actually have to set this up yourself. So whenever you have something like this, step 1, set your equation to equal to 0. That means you have to move that 5 to the other side. You can't add it with anything other than a common term, which is 19, and that gives you a 24. Now you have your trinomial equal to 0. So in step 2, you're going to have to factor this trinomial. And you can use whatever method you think is best. I tend to go with the product sum method because it doesn't have a coefficient, or the coefficient is 1 actually. So that's the easiest thing for me. So here I am looking for factors of 24 that are going to add up to a negative 11 potentially. And I believe 24 divided by 3 is 8. And if I add these up, I'm going to get an 11. But in order to get a negative 11, both 8 and the 3 have to be negative. So I'm going to go ahead and factor that out. It gives me x minus 8, x minus 3. So what do we do from here? Well, step 3, we're going to go ahead and solve for each binomial, for each x. So you're going to have two equations here. Very simple equations, but two. X minus 8 equals 0, and x minus 3 equals 0. You're going to solve for each one individually. That means that this quadratic equation is going to have two answers. It could either be a 3 or an 8. Sometimes that quadratic equation might come like this, where it's not a trinomial. Well, in this case, you just do the factoring thing. You're going to go ahead and factor out the GCF, which is an x, and then solve each one individually. We have x equals 0 and 7x plus 1 equals 0, and solve for x. So in here you have two answers, x equals 0 and negative 1, 7. Go ahead and try to do these two equations on your own. In the next part of the video, I'll show you the answers. Welcome back. I'm going to go ahead and solve these. We're going to move everything to one side so that I have my equation equal to 0. Then I'm going to factor out my greatest common factor here, and I'm going to end up with a trinomial in the middle. And then I'm going to factor out that trinomial. So I have r minus 1. Since that's the same, I'm only going to solve that once. Here I have another trinomial. I'm going to use the splitting the term method for this one because my leading coefficient is a 2. So using the splitting the term method, I end up with 2d minus 3, and d plus 4 equals 0. And there are your answers.